Okay, welcome back. This is still talking about problems 80 through 89 in the test packet. I just want to use one more thing for the protractor before we move on, and that is if I were to give you a line, all right, and it goes on forever in both directions, and it would say, you know, anywhere I could put a little dot to represent the vertex, and this would suddenly become an angle, all right, because this would be the start for this ray, and this would be the start for this ray. So if I did that and I put the vertex right in that little bullseye right there, notice that, let's say I think that this is the beginning side of it. I start at 0 right here and I go until I get to the other ray, and hopefully you notice that it gets you all the way to 180 degrees. So if you have a straight line and you start to think of it as two rays, because you just put a dot on it, the rays that head in the exact opposite directions, and this angle right here that starts here and ends here is 180 degrees. Okay, that's significant because I would like us to talk about triangles right now. So I'm going to put this aside for just a second, and I want you to look at this triangle that I've made. Now, this is not a special triangle. I just kind of drew it and then darkened the edges so that you could see it. Now, we have 3 angles in here. I'm going to number them 1, 2, and 3. I'm just doing that randomly. It doesn't really matter what you number them. But if I go through and I measure each of these angles, there is a rule in geometry that says in any triangle, these 3 angles in the triangle will always add up to 180 degrees. Now, I could do it with the protractor and prove it to you, but I want to do it a simpler way, and that is I'm going to destroy my triangle. So what I'm going to do is I'm going to take it, I'm going to rip off each of the 4 angles, goodness gracious, each of the 3 angles, and we'll watch what happens. So I'm going to rip this right here, and we'll save that, and I'm going to rip this one right here, and we'll save that, that's angle 2, and I'm going to rip this right here, that's angle 3. And what I'm going to do is I'm going to take each of the angles, and these little points right here where the angles, you know, come together. Remember, that little point is called a vertex of an angle. And what I'm going to do is I'm going to put these 3 vertices, that's plural for vertex, I'm going to put them together. All right? And I want you to see what happens. It probably would have been good if I had brought some tape out here to hold these together. But do you see how that makes a perfectly straight line? And we just talked about this a second ago, that when you have a straight line right here, that means that that angle, which is made up of these 3 parts, is a 180 degree angle. All right, so the 3 angles in a triangle, when we put them together, make a straight line, and a straight line is always 180 degrees. Therefore, these 3 angles, angle 1, 2, and 3, have to add up to 180 degrees. And it doesn't matter how I put them in order. If I do these 2 and then this one, all right, it still ends up making that straight angle right there, so that their sum, when I add them together, is 180 degrees. All right, so let me write that down as being very important. All right, the sum of the angles in a triangle always add to 180 degrees. All right, now that's important because they're going to ask you some problems where they'll say, okay, here's a triangle. I just made it up. And this angle is 47 degrees. I like to go with 45 degrees. That's a little bit nicer. And this is, let's say, 50 degrees. And they say, what is this one? They might put an X there. They might put a question mark there. So you would say, well, I'm not sure, but I know that all 3 of these together have to add up to 180. So I would say, well, 45 and 50 add up to 95. All right, so then how much more do I need from 95 to get up to 180, because that's my total? So you could count up if you wanted. You could say, well, in 5 more, I'll get to 100, and then from 100 to 180, it's another 80, so it should be, X has to be 85. Or you could say, let me just take the total and subtract what I know I have already. And then I would do 180 minus 95. That gives me 5. 17 minus 9 is 8, and so it's 85. All right, so they'll give you 2 and they'll ask you to find the third one. And again, this is really important right here. The sum of the angles in a triangle always add up to 180. Not just sometimes, not if it's right, not if it's Tuesday, not if it's isosceles. It always, no matter what kind of triangle you're given, they always add up to 180. All right, so then they're going to expand on that and they're going to give you a quadrilateral. And they're not necessarily going to be nice and give us one of the named ones that I showed you last time. They're just going to give us kind of a weird one. And they're going to give us some measures in here. Like let's say this is 70 and this is 95 and this is 80. And they're going to say, what's this guy? And you might say, I don't know, Mrs. Taylor, you only told me about what to do if it was a triangle. Well, here's the trick with this. This right here is made up of, if I take one of a vertex right here, again, the vertex is just where those two sides meet, and I draw it to an opposite vertex like this. What happens? Well, it makes two triangles right here. What are the angle measures in this one? 180. What are the angle measures in this one? 180. All right. So what's the angle measure in a quadrilateral? It has to be 180 plus 180, which is 360. So we could write another rule here that says the sum of the angles in a quadrilateral always add to 360 degrees. All right, so if I know that this is 70, let me get rid of that line now. Where's my eraser? Right here. If I know that this is 70 and this is 80 and this is 95, 70 and 80 is 150. 150 and 95 is 245. So I have to get from 245 up to 360. Let's see, I'm going to subtract to do that. 360 minus 245. That's 5, that's 1. Clearly my drawing's not that accurate. It's telling us that this is 115. I think that angle's smaller than that one. So my picture was not good, but that's how you would do it. You would take and you would add up the angles that they give you, and this time don't subtract it from 180, subtract it from 360. Okay, I just want to talk about two more things and then I think we're done. One is the word acute, and one is the word obtuse. All right, so first of all, these are both adjectives that describe angles. Actually, we'll put the third adjective, and that would be right. All right, acute, obtuse, and right. All right, you already know what right means. It means that it's a 90-degree angle. All right, acute, think cute and, oh, that puppy's so cute, or your baby's so cute. Think of tiny things generally are cute. And this means it's a tiny angle, all right? Well, what does tiny mean? Tiny means it's smaller than a right angle. So it's an angle that's less than 90. All right, and then obtuse is, it's not right and it's not acute. So it must be, right is 90 degrees, acute is less than 90 degrees, obtuse must be greater than 90 degrees. But less than 180. Okay. All right, this was a lot of vocabulary. I'm really sorry about that. You might want to watch this a couple times just to be able to write everything down, but there's a lot of vocabulary in geometry. So I just want to make sure that when you see these words, you don't freak out and just say, I don't know what that means. So hopefully you'll see them and you'll remember them a little bit, and it will help you when you go through the packet. All right, thanks. Bye.